Hello everybody, I want to speak about application of superheated water as a soil remediation by mathematical model. Extraction of superheated water is a new technology that it has accessibility, low cost and non-toxicity of water as the main solvent because water is a special solvent in chemical process and in this method in a benefit in terms of no need for organic solvent in environmental extraction. And it is a cleaner, cheaper, and faster comparison with other method that the equipment needed for this method is relatively simple and there is no need for applying high pressure as the extraction with supercritical fluid. In this study, a simple mathematical model was presented for the fluid phase, which evaluated the extraction efficiency in terms of temperature, time, and flow rate for the amount of concentration change for naphthalene, phenanthrene, fluorantane, and pyrene. One fluid moves with z direction velocity. 2 solid phase is static. 3 there is no reaction. In the fluid phase, movement is in z direction, so the system is differentially modeled in this direction. According to the fluid stream, the diffusion terms is ignored in this direction, and the convection terms is considered as the determinative factor and described as follows. However, in the radial direction, there is no movement, and lump method is used for modeling, which only contains mass transfer flux. Now the general relation of mass balance, input minimize, output equals accumulation is shown below, and we have initial and boundary condition that you look. The following image is showing the considered system for mass balance by considering a cylindrical shape element with a base area equals to the tower base area and with a height equals. The mass balance is written at the element input at output equation that you look. On the other hand, the mass transfer flux from the solid phase to gas phase is described as follows. By substituting the mentioned equation on this base, that the total mass transfer from the gas phase to the liquid phase is equal to output rate minus input rate plus accumulation rate, we have that you look equation by dividing both sides of the above equation by this that the following relationship is obtained, and we have by considering the below equation NI, and furthermore by defining J as follows. In the above equation, velocity in the direction and the axial disruption coefficient, by substituting the above equation we will have, and by assuming that the axial disruption coefficient does not depend on the direction, we will have equation that you look. Be considering the continuity equation and assuming that the fluid density is constant since the velocity in x and y direction are 0. The above equation turns into the following equation. Finally, we have equation that you look. The above equation is the one of to be solved to solve such an equation to boundary condition, and one initial condition are needed. The boundary conditions are described as follows. In this study, the mass transfer of naphthalene, phenanthrene, fluorantane, and pyrene from solid superheated water were investigated. The information about molecular weights and solubility of these compounds are illustrated in the table. The next slide, you look calculation the solubility equation that has porosity coefficients due to the presence in soil, which is considered 0.4 in this work. The extraction time depends on the kinetic of the process and the time needed to reach the equilibrium. The effect of time on the extraction of hydrocarbon or multiple aromatic is shown in figure As it's obvious, by increasing the extraction time, the concentration of hydrocarbon in the liquid phase are increased. In fact, from a specific time to further, there is no change in the curve by increasing the time, which means it's reached equilibrium. Also, it can be concluded that by increasing the time, the change rate of concentration increases, which can be ascribed to contact time of two phases. In other words, the sufficient time needed for mass transfer is provided by further increasing the extraction time. As can be seen in figure, the variation of polarity is not determinative on the amount of concentration. Also, for various compounds, there is no significant change in concentration, which can be concluded that main resistance against mass transfer is the internal resistance, not the external one. In other words, the diffusion in the solid phase and reaching to surface feel the most resistance overall. The resistance of the liquid phase in low. As shown in figure, by increasing the temperature ranging from 200 to 250, the concentration variation were significantly affected. This phenomenon can be assigned to the effect of this compound solubility, which by increasing the temperature, the solubility enhanced significantly, and this is obvious in figure. The following figure provides a comparison between the concentration change of the four compounds at 2 fluorides and 150 centigrade temperature. As can be seen in figure, the concentration change of naphthalene are more than other, and phenanthrene and fluoranthene and pyrene come next respectively. This order exactly originates from their solubility, which is in the order of naphthalene, phenanthrene, fluoranthene, and pyrene from higher to lower. On the other hand, the molecular weight of naphthalene is lower than other, which influence on the diffusivity in the liquid phase. The lack of homogeneity in the concentration of initial soil, which is heated up to 100 centigrade, can be mentioned. The concentration of remaining naphthalene was also decreased from 30 pressure at 100 centigrade to 0.74 pressure at 30 centigrade. As can be seen in figure 2, the separation of phenanthrene from the soil needs more heat than the value needed for naphthalene, which organized from the properties of phenanthrene that in comparison with naphthalene has a lower solubility in water and higher molecular weights and melting point. It can be mentioned that almost 90–50% naphthalene was extracted at 100 bar because naphthalene was resistant in soil at 100 centigrade that does not separate from the soil. But at 150 centigrade and higher temperature due to its physical properties, which is changed in this condition, it can be easily separated from soil. As is in this study, significant change in concentration were observed in the temperature of 200 and 250 centigrade, which is ascribed to the effect of solubility of this compound that increased by increasing the temperature. Also, the variation of flow rate has a low effect on the concentration for all compounds, which means that the internal resistance is determinative comparing with the external one. In other words, the diffusion in the solid phase and reaching to the surface feel the most resistance. Overall, the resistance of the liquid phase is low. By increasing the extraction time, the rate of concentration change increase, which can be assigned to contact time between two phases. By a meaning sufficient time for mass transfer can be provided by increasing the time. Short extraction time, high quality extract, low cost of indicator needed for extraction, and compatibility with the environment are other prominent characteristics of this method. The more absorption of water comparing with other methods can be mentioned as one of the disadvantages of this method. And one of the limits of this method, high temperature and pressure, can be mentioned, and corrosion is also another important factor that should be considered. It is hoped that the exciting problem to be solved or mitigate in future studies to facilitate the more application of this technology in the industry.